So this is to, this is about the normal distribution from chapter 6. And, that's, we didn't really practice like in the previous quiz, right? So I just found out, I put this in chapter quiz 8. So I'm going to do one, okay? I'm going to do one to see, to test. So this one, the local gas station, the first one, wait 4 days, receive delivery of regular gasoline to replenish the inventory. Wait period, receive inventory known as lead time. Demand during lead time, during these 4 days, measured in gallons are, they follow the normal distribution. So the average is 930 and the standard deviation is 140. So what's the probability that during the lead time means, during the 4 days, the demand of the regular gas will be less than 800. So basically, we are going to, so what we do is it's always easier to draw this. So the average here is 930. Okay, and then standard deviation is 140. So 800. So 800 obviously is here. So we want to know 800, the probability in this area compared to the whole area. Okay. So what we can do, I'm just going to do one, just to refresh your memory. So usually we should do 930 divided, 800 divided by 930. 800 minus 930 divided by 140. Okay, so that's what we should do.
And then to find the z-square.
Yes, to find this score and then look up the table. But since we have Excel, we could just use Excel. And then I think Excel will find us the Z table, I think. Then normal distribution here. So the first thing is the X means 800. And then the average is 930. Standard deviation is 140. And it's cumulative because we want to see this. So it's cumulative. So that's it. So only 17.66% of chance. I forgot to give you the test. So here. So the first question, the possibility that during the next lead time, demand is less than 800. So that means if they only have 800 when they are ordering the new delivery, so they have to, that means only 17.66% of chance that they will have enough. In other words, 83, almost 83, 82.34% of chance they will not have enough gas before the new truck coming in. Okay, so that's how we calculate this. So today, so the reason I review this is just to kind of refresh your memory. So today we are going to talk about confidence interval. So we use the normal distribution concept, but we made a little bit of the adjustment because in this case, we want to know whether or not the point estimate, like we want to see whether or not the mean is actually within the confidence interval range by using the normal distribution table. By how many percent is our confidence interval, okay? So we use a sample to estimate the population mean. So the sample is the point estimate of the population proportion. Okay. So the point estimate is easier to calculate, but it doesn't, we don't really know because we are taking small sample, try to use it to represent the whole population. So we are not sure if it's really accurate, but we can do an estimate by using normal distribution, okay? So this is what we are going to do, and there are several conditions. So when we calculate confidence interval, depends on whatever the information we have. So if we have the population mean from like historical data, and if we have the average, then there are two ways to calculate. So it depends on if we have the population mean, and if we know the sigma, the population standard deviation, that will be less, that will be more difficult to get, okay? But if we don't know the population standard deviation, but we know the sample standard deviation, which we just need to do the sample and then calculate it with that. So that means one, we have bigger sample size, we can use this. When we have big enough sample size, we can assume the sample standard deviation is similar to population standard deviation. But if we have a smaller sample, then we cannot assume that, then we have to use another type of distribution. And I will talk about it. And then we'll have the population proportion. So that's not, instead of mean, we have, remember we have, let's say 10 times of service, 3 times you got complaint. So possibility you got complaint is 0.3. So that's the proportion. And we have P, we have Q. So confidence interval for the mean is the estimate around the sample mean. That will give us a range to see whether or not the population mean is within that range. If it is, that means it's sample, the population mean, and the samples are similar. Okay, so that means the sample is good, and then we will be confident that, okay, the average of this is this number. Okay, we can say something like that.
Is that like the 68% or the?
Yes, so it's all kind of related, but a little bit different, okay? So assumption for 8.2, the sample size has to be greater, equal to 30, it has to at least be 30. So when the sample size is greater or equal to 30, then we can say the sample standard deviation is similar to the population standard deviation. So we could use whatever standard deviation we have to replace the sigma, okay? But because we have a smaller sample, so we have to kind of adjust the sigma to the sample mean. So you see here, this is sigma to sample mean. So the sigma to sample mean is the population standard deviation divided by the square root of and the sample size. Okay, so we have to kind of adjust that. So to get the confidence interval, so it depends on what you mentioned, the sigma, how big we want the sigma or the z value to be, and then we use that to times the standard error of standard error of the mean. Okay, so it looks like this. So very similar to what we learned from the previous chapter, normal distribution, but the only thing different is this. Instead of sigma, we use sigma x bar. So that's the standard error of the mean, which is this. Okay. Yeah. So for this, because the confidence interval is two-sided, plus minus. So if you can see here, okay, so this is alpha, oops. This is alpha divided by 2, because unlike what we did in the previous, just now, like in the beginning for the quiz, we have, remember we have the gas, this is 930, 800, it's one side. But when we do confidence interval, it will always be two sides like one side here, one side here. So if we want the confidence interval, like they say 90%, the confidence interval cover 90% of the data, then this part will be 90%, right? And then this part will be 5%. This part will be 5%. So that's a alpha divided by 2, but that means the alpha is equal to 10%. So this is the difference here. And then another difference is this, okay. So this is the how we calculate confidence interval. And the like what I draw, the opposite of confidence interval is the significance level. That's alpha. So alpha is, it means that the possibility any given confidence interval would not contain the true population mean. So it means that how like error, sort of like error, how many percent of like 10%, if the confidence interval is 90%, then significant level is 10%. It's 10% of the possibility that this would not have the true population mean, because that will be the error, okay, where outside of the confidence interval. So the confidence interval is 1 minus alpha. Okay. And then the Z over the alpha hat divided by 2 is the critical Z score. Okay. So the alpha is a significant level. So it looked a little bit similar, alpha and sigma. Okay. Let's go back. So this is sigma. Sigma is written like this, and then alpha is like this. Alpha and sigma. Okay. So if alpha is 0.1, 10%, then the Z score, half of the 10% is the 5%, will be 1.645. So that means when Z score is 1.645 and negative 1.645 in between this area is 90%. Okay. So we know that in this case, we need to use Z equal to 1.645 times the standard error of the mean. So like here. Okay. So let's say the sample size is n equal to 35. They have a sample mean of 145.5. So what is the, and then the alpha is not alpha, the sigma is equal to 30.2. So what's the 90% confidence interval? Then we calculate by the alpha sigma, we can calculate the standard error of the mean, sigma x bar will be sigma 30.2 divided by 35 square root. It's 5.105. And Z is 1.645. So the interval endpoint, which is also called the, let me see, I have the special term. Okay, I don't. So what is the term? There's a special term for this part. I don't remember, but I think it will be on the next slide. So the interval endpoint will be 145.5 plus the Z, 1.645 times 5.105, will be 153.9. And then the lower critical level will be 145.5 times minus 1.645 times 5.105, 137.1. Okay, so the 90% confident, we are 90% confident that the population mean should be between 137.1 to 153.7, I mean 9. Okay, so that's margin of error. Margin of error is this part. Okay. It's the Z times the sigma x bar. So that's margin of error. So when we have increasing sample size, it will lower our margin of error, because margin of error You see here, the formula for margin of error is Z times standard deviation divided by this. So if the sample size is bigger, this one will be smaller, okay? So that's why when we have bigger sample size, our margin of error will be smaller, okay? So it'll be more accurate. So in this case, we are 90% confident that the mean should be between 137.1 to 153.9. Okay, and we use confident instead of there's 90% possibility. So it's just wording, but it also, we could say there's 90% possibility, but it's probably better to say 90% confident, okay? Because depends on the sample size, the bigger your sample size is, your 90% confident is more accurate. Okay, yeah. So here, it's just these four that whatever we use the most. Usually we use 95% the most. So you can see it's like very close to 1.96, okay? And then 98 is 2.33, 99 is 2.575, and 80% is 1.28. So these are all kind of familiar. I won't, ask you to memorize that, but you should be very familiar with at least this one, 1.96, 1.645. So when the sample size less than 30 and sigma is known, so the population should be normally distributed in order to calculate the confidence interval. Otherwise, we can't calculate the confidence interval. So let's say the sample size is n equal to 18, and they give us a sample mean of 1.28. So if the what is this, sigma is equal to 0.2, so how do we calculate the 95% confidence interval? So what is the 95%? The z-score will be what? 1.96. Okay,
Right.
so be 1.96 times 0.2 divided by 18 square root. Okay. Maybe it depends, but it didn't. Okay. So the population follows normal distribution. Okay. So we have to assume the population follows the normal distribution, then we can use this. So the standard error of the mean is 0.2 divided by square root of 18. So sigma x bar is 0.047. And then for these will be 1.96 times, this will be the 1.96. Okay. And then the standard error, margin of error be this 1.96 times 0.047. So the upper critical level, upper confidence level be 1.28 plus this will be 1.372. And then lower critical level will be 1.188. Okay. So if the sample mean is 1.26, we are 95% confident that the population mean should be within 1.188. So as we know, if the sample size is bigger, then this one will be smaller. Okay, and then it will be more close to the sample average. So the next one, what if we don't know the population sigma? Okay, so if we don't know the population sigma, then we'll have to the S will be divided by n minus 1. Okay, we substitute S in, to calculate the standard error, okay? So for this one, we still use this formula, but instead of using normal distribution, we have to use t distribution. So t distribution is very similar to normal distribution, but when the sample size is smaller. So when the sample size, remember when the sample size is smaller, the x is bigger, right? The sigma x bar is bigger. So
Or margin of error.
yes, it's bigger. So that's why when we use t distribution, this t distribution, the it's still bear shape, but it's flatter. Okay. So, and in this case, we have to use the degree of freedom n-1. So they actually calculate its bear shape is symmetric, but it's flatter and wider than the normal distribution. So one example, so when the degree of freedom, meaning the degree of freedom is just the sample size minus 1. So when the degree of freedom increase, means when the sample size increases, the shape of the t distribution become very similar to normal distribution. Okay. So like this. So when the degree of freedom is 5, it's very flat. And when the degree of freedom is 13, it's like this. But when it's 100, it becomes like normal distribution. Okay. So that's that. So if you, I can go online and I'll show you. So because we don't have a textbook, so we can do t-score. So when we have a t-score, it looks like, let me see. Okay. So it looks like this. So they have different degree of freedom, and it's 1 tail or 2 tail. Okay, so that means like this is 0.5, it's 1 tail, but for 2 tail is 1. And we want this to be this 95%. That means 2 tail is 10%. Okay, so this is 90% actually, 90%. Okay, so like here, we will see, if you can see here, if the confidence interval is the same, but different sample size, see this is becoming smaller, and then eventually it will be very close to the z-score when it goes to 100. So for this, we just need to figure out what is the critical t-score by looking at the table. And we need to calculate the sample standard deviation, and then the standard error of the mean by using that divided by n squared, n square root. So for the sample size equal to 15, and the sample mean is 5.11, the standard deviation, sample standard deviation 0.85. The 95% confidence interval, we will look at, so it's 95%. So each tail is 2.5%. So we look at this. Okay. So we should look at the t distribution, t table. This is 0.025, and the degree of freedom is 14. So the t-score is 2.145. So when we do that, calculate it like the same thing, x bar 5.11 plus minus the t-score 2.145 times the standard error of mean. So, yeah. So the upper confidence level is 5.58, lower confidence level is 4.64. So if the sample standard deviation, sample mean is 5.11 and sample size is 15, we are 95% confident that the population mean will be between 4.64 to 5.58. Okay. And then the next one is the proportion. So proportion, we have, wait. Oh, this is the one example. Okay, so because the sample size is less than 30, so in this, and we don't have population standard deviation, we have sample standard deviation, so we have to use t-score. And then we have to look up the degree of freedom is 20, and then the one tail 10%, two tail is 5%, like 0.05. Okay. Cool. Yeah, so that's what we should calculate. And then so proportion data, they follow a binomial distribution, but when it's big enough, so that means if this actually should be P. Okay, the probability of success, the probability times the sample size is greater than 5 over populations, and the population size times Q minus pi is greater than 5. Then these will follow the normal distribution. Okay, and then the P is just X divided by N, and standard deviation of the P is P times Q divided by N square root. Okay, it's all similar to what we had before. So yeah, so now it becomes, now they change it to P times minus P, just so it's the same P times Q. Okay. So similar to what we just did, these 4 times the standard error of the P. Okay, so like this, and we'll calculate upper confidence level and lower confidence level. So the margin of error is this. So just one example. So random sample of US citizen, 22 out of 100, they are found to have blue eyes. So it means 0.22% have blue eyes. Okay. So what's the 98% confidence interval that we have blue eyes? What's the proportion? Blue eyes. So it would be 0.22 times 0.78 divided by 100 square root, which is 0.041. That's the standard error of P. And then 98% for Z is what? Is it 2.28? Let me check. I remember. I try to remember, but I can't. So here. Oh wait, not here. Here. 2.33. 2.33. Okay, so Z is equal to 2.33. So this one, 2.33 times 0.041. Okay, and use the P plus minus the standard error margin. And then we got 0.316 and 0.124. So we are 98% confident that the population proportion, the population, the US citizen have blue eyes is 12.4% to 31.6%. Okay. So that's it. Any questions? So this is just some calculation. So 90% confidence interval estimate population proportion, sample proportion equal to 0.36, and the sample size is 125. So how do we calculate that? So that's 10%. 10% is what? 1. I forgot again. 68. See 1.68. And let me look it up. 10% is 1.645. 0.645. Here, 1.645. Okay, so let's do it. So the Z of 0.05, because we have to divide it by 2, it's 1.645, right? T is equal to 0.36. And then this sigma is 0.36 times 0.64 divided by 100, right? So it would be, oh my goodness, it would be 0.6 times 0.8 divided by 10. I think. So it will be 0.048. Could you use the calculator to even 0.048? It would be good.
Yeah.
Yeah.
Nice.
So because this you can always take square root.
Right.
Yeah, so it would be the same as square root of this times square root of this, and then divided by square root of this. So it'll be 0.6 and 0.8 divided by 10. Yeah. So 0.048. So wait. No.
Divided by
It's,
125.
yeah, it should be 125. Gee. Stupid. Now I can do. This 12, 11, close to 11. So what is it?
I got 0.043.
Okay, 0.042. Yeah, it should be very close.
Yeah.
Yeah. So, so that's the standard error of the P. Okay. So the confidence interval will be 0.36 plus minus 1.645 times 0.043. What is this one?
Oh,
Then the error of the mean. 0.4.
0.07.
0.07. Okay. Yeah, it's possible. Yeah, 0.07. So 3.36 plus 0.07. So it will be between 0.29 to 0.43. That's the answer. Okay. So the next one. So remember when we come back, let's come back here. You know, we can calculate the margin of error, but the margin of error is decided by the sample size. So now, if we know the confidence interval we want and we know the mean, we can convert it back to decide what's the sample size that we need. Okay. But some stuff include, some don't get. So several conditions. When the first one is when we know the population mean and when we know population standard deviation, it will follow the normal distribution, okay? But we should check the sample size, see if it's big enough, okay? And for the second one, we have population mean, but we don't have population standard deviation. We only have the sample standard deviation. In this case, we definitely need to check the sample size, see if it's big enough, but we can use the t distribution to check the value, the t-value. And for the third one, we will use the z-value, okay, to find out, you know, what's the reasonable sample size. So for this one, how do we figure out what's the reasonable sample size? So the margin of error is this. So that means the sample size. So when you convert, when you kind of, you know, move around your formula, okay, like this. So basically we can move, oops. So here, this is the margin of error, it's the d times sigma divided by n squared. So if both sides we times this would be here, this should be here, and then we'll move this here. So it'll be d times sigma divided by the margin of error. Okay. So the sample size should be the d squared times sigma squared divided by margin of error squared. So for D, so for example, if the sigma is 45, and what sample size should we have to be 90% confident when we try to estimate the population mean with margin of error of 5? Okay, so Z for 90% is what? 1.645, right? So 1.645. And the required sample size will be the 1.645 square times the sigma square divided by margin of error square. Okay. The sample size should be, we have to round it up to 20. Okay. Let's just to calculate it backward. And then for this one, unknown, what's the sample size? So it will be n will be equal to t squared s squared divided by this, right? But how do we find out t? We have to look at the degree of freedom to find out what t is.
Right.
And degree of freedom is connected to n. So we can find we can solve this, okay? So when we don't have the population standard deviation, we can. But we don't need to, because in this case, remember the degree of freedom goes from 0 to all the way to 100. So that's how it's designed. And different degree of freedom, they have different t-value. So this is okay. Yeah, so in this case, we don't really need to worry about the sample size, because if it's just 3, we could find degree of freedom 2. To find the t-score, okay? So let's solve. For population proportion, very similar to this one, okay? N will be d squared times p times q, because see, this is where the formula is, right? So and then divided by margin of error. So same thing. So for 95%, what is the Z? Yes, 1.96. So 1.96 will be 1.96 squared times the P 0.22 times 0.78 divided by 0.05 squared. Okay. Which are only going to be 5%. So. Yeah. So in this case, the sample size will be 263.96, but I always have to round up to 94. Okay, so that's it. Any other questions? So we don't, we don't have to memorize the formula, it's here. So you can always look it up and then just do the calculation. And just basically convert it back. So do you want to try?
Sure, yeah,
Sample standard deviation. What is the number one?
I got 97. All right,
Number one is sample standard deviation. So you are not, we
Oh.
can do that.
okay.
Okay, that's number one. Number two. Sorry. Three.
Wait, so number 2 is also sample.
It's population standard deviation. See that?
Oh,
Right?
Yeah.
So it's different. Sample standard deviation and population standard deviation. So sample standard deviation.
not 68. for number 2.
You're probably right.
Yeah.
I don't,
Oh,
we might have how about the third one? We might have the answer. Oh, wait, we don't. So 90% confidence is 1.645 squared times P. P. How much of error? Kappa times 0.22 times 0.78 divided by 0.01, right?
yeah.
So yeah, so you know how to do that. And another thing is, and one like exception, we don't really, I don't think we have it in our quiz, but for the sometimes if the population, like we usually assume population is infinite. But if the population is not big enough and our sample size is divided by the population will be greater than 0.05, that means our sample, if our sample is 5% of population, then in this case, we have a finite population, okay? And the finite population overestimate the standard error, so we will need to adjust it by using the finite population correction factor. So use the population size minus sample size divided by population size minus 1 and then square root. Okay, so that's the only thing. So in this case, you see here, this will be just estimate that will be adjusted by times this. Okay, so that's, and then for the population standard deviation unknown for T, we also need to adjust that. But we don't really, like, it's very rarely we will use this. Okay, but just, you know, something that I thought we could mention. Yeah. So this one is similar to, you know, how we just calculated, so we can skip it. How about this one? 99% confidence interval. 2.96.
Yeah.
Oh, so this one you will have to adjust. So you don't have to worry about this. Oh, yeah. So like this one is just some example. Text return, okay? But as I say, you know, we don't have to worry about this now. So that's it for this chapter. Any questions? So quiz 9, we will have confidence interval. So pay attention to the standard deviation. It would usually say population standard deviation or sample standard deviation. Okay, so for this one, okay, for the second one, we have sample population standard deviation. So we need to calculate the sample, the margin of error by different sample size. And then the third question is population standard deviation. Fourth one is also population standard deviation. So we only do population standard deviation in our quiz now.
Okay.
So it should be quite straightforward. Because we don't have this table. But we actually can use that here, confidence. So we can actually calculate the confidence interval by, you know, like alpha. We just use one example. So the standard deviation alpha is the error. And then standard deviation is, oh, there's no, wait. Calculate first. Standard deviation 39. And then size 35. How come this one doesn't have a mean? That's weird. So this is the standard error of the, so yeah, so this is the margin of error. And then we can just use 247.8 plus minus, I think. Need to calculate it. Do the T. So this is 35, we have a smaller sample. Okay. Oh, this number 3. This is the example here. 0.1, 1.645. Let's use this. So 30.2. 30.2, yeah, I think I need to change it to 0.05. 30.2, 35. And also 35. So let's see if this is, yeah, so we have to, if it's half, if it's 2 tails, we have to do 0.05. So 5.105, is it correct? No. So let me change it to 0.05, see if it's correct. Oh. Oh. I think I'll do it. Nice. 5.145. So, okay, so we don't have to adjust it, it should be 0.1. Because they were already, yeah. So this is just, I think some rounding,
Okay.
yeah, so we could just put the alpha. I want to put alpha divided by 2. So. Yeah,
I just had a question about the new panel.
okay, wait, let me exit this.